Welcome back. This is a second video to show you another example using U substitution. One of the things I want you to keep in mind is how do I know I'm supposed to be using U substitution? Well, generally you will see a composite function. When you see a composite function, you know U substitution is more than likely the technique you will need to use. In this case here, I'm looking at an x on top, x squared plus 1. It doesn't quite seem like a composite, except that you do have a fraction with x and x squared on the bottom. I'm going to kind of separate these a little bit so you can see a little bit what's going on a little bit more clearly. So 1 over x squared plus 1, and I'm going to multiply that by x. So I'm just kind of separating these so you can see them better. And then I still have my dx. Okay, another hint that you're using substitution is when you can't really do the antiderivative in your head. That kind of gives you the hint. So I'm looking at this and I'm trying to decide what is u going to equal. Well, I need to pick the function that is in the most complicated position. So I have x is in the numerator, x squared plus 1 is in the denominator. So clearly x squared plus 1 is in the most complicated position. But another hint is that you should be able to take the derivative of this function and get that derivative somewhere in this expression. So for instance, if I take the derivative of x squared, I'm going to get 2x plus the derivative of 1 is 0. Now, I don't have a 2x, but I do have an x, and that's what's important. The 2, the coefficient, we can work with that, but I do have an x. If I had let u equal x and I took the derivative, I would get 1. Which is here, but then what about this expression on the bottom? What do I do with that? So again, you want to pick the function with the most complicated position, and then you also want to make sure that when you take its derivative, it appears somewhere in the expression. So let's go ahead and get started. U equals x squared plus 1. Now the first thing we're going to go ahead and do is we're going to take the differential of both sides. So the derivative of u is 1 times du. We're now going to take the differential of x squared plus 1, which is 2x times dx. Now, when I go back to my expression here, I'm going to be able to replace this with u. X squared plus 1, the entire expression is just going to become u. So that's going to be 1 over u. And this x dx, I need to make sure that I have something to replace that. Now, I do have a 2x dx, but this isn't 2x dx, it's just x by itself. So something we can do is we can divide both sides by 2. And so that gives us 1/2 du equal to x dx. And now we have exactly x dx show up right here, which means this x dx can be replaced by 1/2 du. Okay, so 1 over x squared plus 1 got replaced with 1 over u, and x dx is going to get replaced by 1/2 du. Now I got to bring my integral with me. To clean this up, I'm going to take my constant and just take it outside. Just makes things a little easier. You don't have to do that, by the way. You can leave it in, but it just cleans up the integral so you can take that antiderivative a bit easier. Okay, so that's nice and clean. Now I'm going to need to put my boundaries. Remember, 2 and 3 are the boundaries for x. We're now in terms of u. So we're going to go over here and plug in our 3. So that's going to be 3 squared plus 1, that's 10. And then I have u of 2. So that's going to be 2 squared plus 1, which is 5. So that means this lower boundary is 5, this upper boundary is 10. We are now going to proceed with the antiderivative and plug everything in. Well, let's start with the antiderivative. My 1/2 is outside. My boundaries are 5 to 10. If you remember from the previous video, the antiderivative of 1 over x I said was natural log absolute value of x. Same concept, we're going to use u in this case. So natural log absolute value of x, oops, let me fix that, of u. There you go. And so now we're going to go ahead and keep the 1/2 in mind and plug in our boundaries. We're going to get natural log of 10. Absolute value of 10 is just 10 minus natural log of 5. Now, I don't actually know the estimation of those, and you don't need to. You can leave it like this. I'm going to go ahead and distribute the 1/2 just to make it a little nicer. So natural log of 10 over 2 minus natural log of 5 over 2. And that is our answer. Okay, example number 2 is done. You can go ahead and check out the next video for example number 3.